There's three ways to deal with this sort of modeling quadratic question because there's three ways you consider your quadratic. You could either write it as a general quadratic and then substitute points in. This will work. You'll just have to also look at the derivative and set it equal to 0 for the maximum because we're going to need to have three pieces of information. I'm not going to do it that way. There are times when it will work, but I don't think it's the best. Secondly, you could factorize, try to factorize, but in this case, we don't have any information on the roots. Like if you knew that where it was hitting the ground, then yeah, factorization is great, and you would do like a times x minus your roots and so on. This just leaves us with the third method, which I tend to see in the exams is the one that comes up the most. It's when we have the maximum, right, let's use completed square form. That is what I'm going to do here. So I know that the maximum is occurring when x is equal to 9. I can straight away write down that h is equal to, I'm going to write x minus 9 squared plus some constant, but it's not necessarily just x minus 9 squared. I need to put an a here, and then I'm going to make this one b. So the great thing about this is I've already kind of dealt with the maximum, even though I don't know what the value is, and I've only got two other constants. So I've avoided having like the ax squared plus bx plus c situation. And we've got these two values, so we can sub them in. We're going to create simultaneous equations. It's actually going to be really quick. So this is my advice, but do practice all of the modeling questions, and they might be slightly different. You know, sometimes you might deal with the factorization. If you got the roots, then yeah, go for that. If you have like 3 points but not the maximum, then yeah, go to the ax squared plus bx plus c. But as soon as the maximum or the minimum is involved, I think this is the best one. You avoid differentiating and things like that. So let's sub in. Just wanted to like talk a little bit about it rather than just go ahead and simply do it. So if I sub in, I'm going to get 2 equals 81a because it's 0 minus 9 and then squared plus b. And I'm also going to sub in the second point, so 0.8. 20 minus 9 is 11, so I'm going to get 121a plus b. I'm going to do the bottom one minus the top one, because then I'll get a positive here, 40a, and then I'm going to get minus 1.2. And a is then, if you put it in your calculator, minus 0.03. And then substitute back in to get b, we get b equals 4.43. You can even just put these directly in your calculator to be fair. Sorry, not these ones. I'd say because of the simplicity, because B is the same, I know there's a 0.8, like it is just going to be easiest to do what I did here, but let me show you how you would do it. So you go to, it's a home and then to equation. Like in mechanics questions, this is definitely a good shout to go with. Two unknowns and then type them in. It was 80, so A is going to be x, 81a plus b is equal to 2. Sorry, let's go back. If you make a mistake, it's all right. 1 and then 2. And then it was 121a plus b. You can see the time. I mean, I know I'm doing it slower than you will be, but the time it takes, I suppose you can be a bit more assured that you've got it correct. But there we go. There's our a, and there's our b, and we can change it using format into like a decimal 4.43. Anyway, that's what we've got, and that means I've found h in terms of x. H is going to be minus 0.03 x minus 9 squared plus 4.43. Yes, it's not expanded or anything, but don't worry about that. You can, but completed square form is really useful because it straight away gives you the maximum value, and because it's going to be 4.43. That is when x is 9, we get 4.43. And you could very quickly find the roots as well if you needed to. In B, we're asked to give one limitation of the model. And there's lots of things you could say. Like if you were talking about the equation, you might say that it would sort of just carry on going down through the ground. But really, I think in this sort of question, it's looking for an actual kind of mechanics issue with our model. And um, there's lots of things like we're assuming that we've got this like perfect parabola that's symmetrical, and in real life, when you throw a ball, that it doesn't happen. So my go-to is always air resistance. Air resistance has not been considered. Now, it doesn't mention that, but we know that's true because it just wouldn't look like this. But some other ones, I mean, there's a whole list. You could just say it's unlikely to be a quadratic function, not even give a reason. Unlikely to be parabolic, that's the same thing. Wind, that's always a good one to bring in. Air resistance, unlikely to travel on a vertical plane. So vertical plane is just when it's like moving through sort of a 2D plane. It's not veering off to the left or the right. Like if I try and ever play pitch and putt, I always seem to veer the ball off one where I can never control it. But yeah, you get spin on the ball on purpose or by accident. So this is going to be true even when a ball is being thrown. Ground's unlikely to be horizontal, could say, could be hazards in the way. Shape of the ball may affect the motion. So others will be accepted, but yeah, just a reason that's suitable as to why the model may not be appropriate or where it would break down. It doesn't actually mention it like going through the ground, but I suppose you could just say the model is valid up to that point there, and then that wouldn't itself be an issue. In the last part, we're told that Chandra is standing directly under the path of the ball at a point 16 meters horizontally. So let me put them here. And Chandra can catch the ball if the ball is less than 2.5 meters above the ground. Okay, they've got quite a long arm here. Um, but yeah, maybe they can catch the ball if it goes there, if it's less than 2.5 meters. Use the model to determine if Chandra can catch the ball. So let's work out the height of the ball when x is 16. And we'll compare it with 2.5. So you just got to substitute in. We're going to get minus 0.03 multiplied by, you put it in your calculator like this, but 16 minus 9 is going to be 7. So we're going to be timesing by 49, then adding 4.43. And this ends up giving us 2.96. So actually, it's above that height at which Chandra can catch the ball. So in fact, this probably was a decent representation. They're trying to catch it, but it's a little bit too high. So I would say this is less than, sorry, greater than 2.5, and then write a little conclusion. So Chandra cannot catch the ball.